Okay, here's our problem for elimination where both have to change now. And this is the one where it gets a little messy. Usually we make a simple mistake someplace, maybe a sign mistake. But let's go ahead and take a look. Can I make the 2 look like a 3 or the 2 look like a 7? Or vice versa. Can I make the 3 look like a 2 or the 7 look like a 2? Answer is nope. 2 times nothing, that is a whole number, would make it into a 3, or 2 can't make it into a 7. So what we're going to do here is we're going to change them both. Now, you get to choose. Do I want to make the x's look like a common value, or do I want to make the y's look like a common value? And in this case, there is no better choice. They're both pretty much going to be the same level of difficulty. So I'm going to choose 2 and 3 because first, they're smaller number, and also they're both positive. I'm not going to make a mistake with positive numbers. So here's what we're going to do. We're going to change them to a common number. And a common number that 2 and 3 can both change to, morph to, is 6. I can change 2 to become 6, and I can change 3 to become 6. Now, each of these has its own game plan, and I'm going to change the top to 6. But remember, being 6 and 6, one of these have to be negative. So I'm going to actually make the top negative. You can make the bottom negative, whichever one you think is going to be easier. Thank you, Aaliyah. So I'm going to multiply this by 3. But the top, I'm going to multiply it by a negative 3 on top. I'll multiply the bottom by a positive 2. Now, just to quickly reflect, if I multiply 3 times 2, that gives me a 6, but a negative 6, and 2 times 3 would also be a 6, and that will lead us to getting rid of our x's, eliminating our x's. So let's go ahead. In this case, since I'm changing them both, I'm going to rewrite it. So here we go. Negative 3 times 2 and negative 3 times negative 7 is going to be negative 6x plus 21y equals to negative 3. On the second equation, multiplying everyone by 2 and 2, 2 and 2, that's going to give us positive 6x minus 4y equals to 20. So not only did the first equation have to change, the second equation also had to change. Oh, great. Now the x's eliminate. Negative 6 plus 6 becomes 0, and we're left with 21 minus 4 is 17. Y is equal to 20 minus 3 is also 17. Y is equal to 1. Now, if I know y is equal to 1, we still have to look for x. Let's look for x. So we're going to plug in the equation. Now, here is my hint. You could use these new fat equations, but just use these original equations. So you can pick whichever one you think is easier. I'm going to choose the 2 just because. You don't have to, but I'm going to choose the 2 just because. The 2x minus 7y equals to 1. 2x minus 7 is equal to 1, multiplying the 1 and 7, plus 7 to both sides. 2x equals to 8, x equals to 4. We're dividing by 2. Okay, so my solution for the set is 4 comma 1. Now let's see if this works. We have 2 times 4 minus 7. Oh, let's use the second equation just to mix it up. 3 times 4 minus 2 times 1. Would you equal to 10? I don't know. 12 minus 2 is 10. Yes! We found a solution for the system. We found a solution for the system. Okay, so today what you guys are going to be working on is these types of problems. But also, we're also going to work at word problems. So for the iExcel, I included this general solving a system through elimination up to a SMART score of 90. And then there's two word problem ones. One's with substitution and one with elimination. I'm going to go through those examples right now for you guys. So the word problems look like this, and they look a little scary. They really do. But there's always some tricks to solve these word problems. So let's go ahead and read this. We'll write a system of equations to describe the situation below. Solve using substitution, fill in the blanks. So you always have to read. A lot of stuff is just kind of filler. But band students are tested on and required to pass a certain number of scales during the year. You could have just said, math students are required to pass a test. Okay? As of today, Shannon has passed 13. Shannon has passed 13, and her friend, Farid, has passed 9 of them. Okay? Going forward, Shannon has to commit to passing 1 per week. Farid has to commit to passing 2 per week. At some point soon, the two friends will have to pass the same number of scales. How many scales will that be, and how long will it take? So we can start off this way. We said Shannon has already passed 13 scales. Right? Shannon has passed 13 scales. This is Shannon here. This is Shannon, and this is Shannon. And then she agrees to pass 1 scale per week. After so many weeks, it'll be a total. Some total. Okay. So if she worked 1 week, she would have passed 14 scales. If she worked 2 weeks, she would have passed 15 scales. If she worked 3 weeks, she would have passed 16 scales. So whenever you write these easy equations, go ahead and double check it by plugging in some examples to make sure it kind of makes sense. So let's go ahead and look at the second one. Farid passed 9 already, and he has to pass 2 per week for some total. Now here is the big takeaway. You have to be aware of this last point. At some point, the two friends will pass the same number of scales. The total will one day be exactly the same. And for us, that means this number here has to equal to this number here. So if they are the same, that means I can set them equal to each other. Because if Shannon's total, right, if let's say you're taking a test, her total has to be the same as Farid's total if you want them to pass. So they both, in this case, specifically tell us they have the same number of scales. And that's a hint. Now looking at this problem here, we're solving for W. Let's minus W to both sides. We're left with 13 is equal to, 13 equals to 9 plus W. And then we could minus 9 to both sides. W is equal to 4. So W stood for what? It stood for weeks. Now I like to label my variables after the words that we're looking at. So this could have been total, could have been S for scales. Right? W is for weeks. And then the friends will each have to pass how many? So we answered one part of the question. We want to go back and say, hey, well, okay, what is the total number of scales that they have to pass in? If it takes 4 weeks for them to reach that goal, we just plug 4 here. 13 plus 4 times 1 is 4. It's going to be 17. Let's see if the second one came up exactly the same. 9 plus 2 times 4. This would be 9 plus 8 is 17. Yep. So they would both have to pass 17 scales in 4 weeks. So here's another word problem, but this time it's going to be focused on elimination. So I'm going to focus on just writing the setup, and then it's just like solving any other elimination problem. An employee at a party store is assembling balloon bouquets. For a graduation party, he assembles 9 small balloons. Okay, so let's mark this. This is 9 small balloons and 5 large balloons, which use a total of 163 balloons. Dang, that's a lot of balloons. That's our total. Then for a Father's Day celebration, he used 89 balloons to assemble 7 small and 2 large bouquets. So we have 89 balloons total, 7 small and 2 large. How many balloons are in each bouquet? So we have 5. So let's do the first equation. We have 9 somethings and 5 somethings. Now, you could call this X and Y. That could be great. But oftentimes then you get confused. What was X? Was X a small balloon or a large balloon? So common sense would say, let's just call this S for small balloon and L for large balloon. And how many balloons do we have total? We have 163, and we added the small balloons and large balloons together. Now go ahead and test your formula. And please don't put big numbers. Just pick small numbers. If I had 1 small balloon and 1 large balloon, okay, we would have 9 plus 5 is 14. Okay, remember, these are bouquets, so they're sets of small balloons. These are sets of large balloons. So the question in the end is, how many balloons are in each type of set? Okay, so if I bought 1 pack of small balloons, I would end up with 9 small balloons. If I buy 1 bouquet of large balloons, I would end up with 5 large balloons. So I need to now find a combination to get that to 163. But with 2 variables, they give us 2 equations. Let's look at the second equation. It's going to be the Father's Day celebration was a total of 89 balloons, and this was made up of 7 small balloons and 2 large balloons. Now we have 2 variables, 2 equations. Now we can solve it. Now for this one, we have to change 1 or 2 equations. Looking here, 9 doesn't become 7, and 5 doesn't become 2. So what number can I make them come close to? Well, look here. I can make 2 and 5, 2 and 5. I can make that look like 10. So I think that's what I'm going to do. I'll multiply the top by 2 and the bottom by 5. The top by 2 and the bottom by 5. Remember, you multiply to both sides. And which one do you want to make negative? It's 100% up to you. I would probably make the top negative, just because there's no real reason. You can make the bottom negative, okay? And then that's how we would proceed to solve this problem. So to finish up this problem, as we mentioned before, I'm going to multiply the top by 2, but more importantly, I'm going to multiply by -2. Please make sure you do write the parentheses if you include a negative. It makes it a lot more clear, so you don't think you're minusing 2. I'm going to rewrite that as negative 18s minus 10L equals 2. That's a big number. That's going to be 200, 300, negative 326. If you guys don't know how to multiply quickly, multiply front to back. 2 times 100 is 200. 2 times 60 is 120. So that 200 became 320. And 2 times 3 is 6. You can practice that. Multiply front to back. 2 times 100 is $200. 2 times 60 is 120, making that 200 become 320. And then 2 times 3 is 6. On the bottom, that's going to be 35s plus 10L. Yeah, they're going to cancel. And 5 times 89 is 5 times 8 is 400. And then 5 times 9 is 45. So it's 445. Okay, again, 5 times 80, right? 5 times 89 is 5 times 80 is 400, and 5 times 9 is 45. All right, This looks really messy, but we're gonna subtract it. It'll come out hopefully pretty nice. So 35 minus 18 is 17. Those go away. And this is going to be 111, I think. Is that right? Let me check that. Get out my calculator. 445 minus, oh, whoops, 119. I forgot I borrowed a 1. Can we divide that by 17? So S is equal to 7 because we divided both sides by 17. Okay, now that I know S, we need to solve for L. So for small balloons, every bundle, every bouquet of small balloons comes with 7 small balloons inside. Yay! Now I'm going to either use the first equation or the second equation to solve for the next variable. I personally will choose the second one because the numbers are smaller. So 7s, which is 7, plus 2l is equal to 89. So 49 is plus 2l equals to 89. Minus 49 to both sides. 2l is equal to 40. Then we can divide them by 2. While the large balloon comes in a pack of 20. All right. All right. Now to double check, since we use the second equation here, I'm gonna double check using the first equation. 9s plus 5l, would that give me 163? 9 times 7 is 63. 5 times 20 is 100. Ooh. 63 plus 100 is 163. Yep, we found the solution that worked. So we have, to rewrite this, we have small balloons are 7, and large balloons are